Welcome to Spaceverse, your portal to cosmic adventures. In a quiet corner of the sky, 650 light-years away in the Serpens constellation, two stars are being born. And thanks to the cutting-edge capabilities of NASA's James Webb Space Telescope, we can now witness this cosmic moment in greater detail than ever before. This is LINS 483. Captured in breathtaking clarity using high-resolution near-infrared light, Webb's view of LINS 483, also known as L483, reveals something extraordinary, a pair of protostars in the very act of formation. Swirling clouds of orange, blue, and violet gas and dust surround the central stars. These are not just pretty colors, they're signatures of violent, powerful forces at play. Protostars don't just sit quietly as they grow. They erupt. As these infant stars accumulate material, they periodically unleash bursts of gas and dust back into space. Some of these jets shoot out at incredible speeds, tight, focused beams of matter slicing through the void. Others move more slowly, but still with enough force to stir the surrounding cloud into motion. These eruptions aren't rare. They've been happening continuously for tens of thousands of years. And what happens when fast-moving gas collides with slower, denser particles? Chaos and chemistry. The collisions trigger reactions that give birth to complex molecules. Over time, clouds like the one in L483 become rich with ingredients: carbon monoxide, methanol, and other organic compounds, some of the very same building blocks that may one day contribute to planets or life. Zoom in, and Webb's powerful instruments reveal even more. With its near-infrared capabilities, Webb's NIRCam pierces through the dust, uncovering delicate, asymmetrical lobes, structures that ripple outward from the center like a pair of mismatched wings. These lobes are where stellar winds and gravity are waging a battle, shaping the future of the system. From a distance, the lobes appear to intertwine, a dance of light and shadow sculpted by forces we're only beginning to understand. The two stars inside LINS 483 are still in their earliest phases of life. They are hidden, nestled within this cloud, growing larger with each passing day. What we're seeing here is stellar infancy, the celestial equivalent of the first heartbeat. And it's all happening hundreds of light years away, yet right in front of our eyes. Thanks to the James Webb Space Telescope, we're not just observing the universe, we're exploring it in a way humanity never could before. We're witnessing the chaos and beauty of starbirth. We're decoding the chemical recipes of future solar systems. And we're unlocking the secrets of cosmic origins, one glowing nebula at a time. Amidst the vast stillness of space, in a cradle of gas and cosmic dust, a quiet, powerful drama unfolds. This is where stars are born. What you're seeing here, this spectacular interplay of light and shadow, centers around what scientists call a protostellar disk. In reality, it's just a single pixel in a telescope's image, but packed into that tiny space is an extraordinary scene. A disk of cold, opaque gas and dust, flattened like a pancake, but vast beyond comprehension, rests like a bed of dark silk. Nestled within it are two young stars, still forming, still growing, still hidden from direct view. These two protostars are the engines of everything happening here. Surrounding the disk is an hourglass-shaped structure, carved out by the stars themselves. As material funnels into the disk and jets of energy erupt outward, the starlight attempts to break free. And where the dust is thinner, just above and below the disk, the light escapes. What you see are towering orange cones, translucent beams of color stretching into the blackness. This isn't an illusion, it's light scattering through gas and dust, filtered by the structure itself. It's cosmic architecture, shaped by radiation. But equally important, and just as telling, are the shadows. Look closer. Perpendicular to the glowing cones are broad, V-shaped areas so dark they seem to swallow the light. You might think there's nothing there, but that's exactly the point. The dust in these regions is so incredibly dense, it completely blocks the star's light. It's not absence, it's concealment. The darkness is the story. These are the regions where starlight is silenced, where matter clumps so tightly, not even infrared light escapes easily. Yet, in the middle of this obscurity, there's still a faint glow. With the sensitive near-infrared camera, NIRCam, aboard NASA's James Webb Space Telescope, astronomers have been able to peer into this murky veil. There, hidden behind layers of dust, lie distant stars. They appear as soft orange dots, just barely visible like embers smoldering beneath ash. And when the dust thins, when the sky clears, the stars erupt into clarity. Bright specks of white and blue shimmer like diamonds scattered across a dark velvet sky, reminders that even in the most hidden corners of space, light persists. This is what makes James Webb so remarkable. It doesn't just show us stars, it shows us the birthplaces of stars. It reveals the scaffolding of galaxies, the texture of time, the stories woven in dust. In this hourglass of creation, we are witnessing not just physics, but a glimpse into the past and the future. Because one day from clouds like these, entire solar systems will emerge. And maybe, just maybe, worlds like ours will take shape, clasped in a bed of dust. Across the canvas of the cosmos, the James Webb Space Telescope is painting an intricate portrait of stellar birth and the chaotic beauty that comes with it. Now we're turning our eyes to one of its most striking scenes, LINS 483. Here, in this cosmic nursery cloaked in cold gas and dust, something spectacular is unfolding. Jets and outflows from infant stars twist and bend through space, forming patterns unlike anything we've ever seen before. Focus your attention on the upper right corner of this image. That brilliant orange arc? It's not just a splash of color, it's a shock front. A sudden curve in a jet, forced to slow down as it collides with denser material in its path. It's cosmic traffic where energy slams into resistance, and art is the result. Now, look a bit further down. Orange melts into pink, and the structure becomes tangled, almost chaotic. Here, the symmetry vanishes, replaced by a muddled confusion of light and matter. These features are so fine, so unprecedented, that even scientists don't yet have an explanation. This is the beauty of Webb. It doesn't just answer questions, it asks new ones. Direct your gaze to the lower region now. See how the clouds thicken. The gas and dust here grow more opaque, more complex. If you zoom in, you'll notice tiny purple pillars, ghostly structures carved by the relentless stellar winds blowing outward from the central stars. Each pillar is shaped not by accident, but by the dense material it contains. Material too thick to be swept away just yet. These are the silent survivors in a storm of radiation and motion. But even Webb, as powerful as it is, can't capture the entirety of L483 in one frame. This image, stunning as it may be, only reveals the upper section of the system. To complete the picture, astronomers turn to archival images from earlier missions, like those from the Spitzer Space Telescope, piecing together the full narrative of this cosmic birthplace. Over time, we'll uncover more. By studying the history of ejections, tracking the symmetries, the deviations, the outflows, we can reverse engineer the life story of these stars. Advanced models will simulate how the jets behaved, how the molecules formed when matter collided, and how much material was hurled into the void as these stars took shape. Each answer brings us closer to understanding not just what we see, but how it came to be. Millions of years from now, when these stars have finished forming, they may resemble our own sun in size and mass. Their wild ejections, now brilliant and translucent, will be swept away by stellar winds. The dense clouds will clear, and what may remain is a disk of dust and gas, a seedbed for planets. This is how solar systems begin. And the name L483, it's more than a catalog number. It honors the legacy of Beverly T. Linz, the American astronomer who painstakingly mapped dark and bright nebulae in the early 1960s. Before the internet, before digital files, she examined glass photographic plates from the original Palomar Observatory sky survey. By eye, by hand, she marked these birthplaces of stars. Decades later, her catalogs remain vital, bridges from the past to the present, guiding modern astronomers as they use tools like Webb to peer deeper into the universe than ever before. So when you look at L483, remember, you're not just seeing stars in formation. You're watching time, dust, and data converge into light, into motion, into legacy. If you enjoyed this journey through space and time, don't forget to like, subscribe, and ring the notification bell so you never miss the next voyage with Spaceverse.